straight? Oh,
Yeah, you gotta go straight here. This is how we do it. Alright, Mr. Kaplinger, this is our physics project. Today we're gonna teach you a lot about Aristotle's views of the universe. By the way, you're looking at the corner of Punchbrook and Route 4 in Burlington.
I extremely dislike this intersection.
I know, it's really hard to see over there. Alright, well we'll start talking about physics later on. But for now...
I just want to go straight.
I know, right? It's so hard. So Aristotle, he's over there in Greece. He's got 5 different elements of matter. The heaviest element is earth. It's pretty much what you see in the dirt, in the plants, and all that stuff down here on the ground. A little bit lighter than that, you've got water, all that liquid stuff in the oceans. It's lighter than earth, but heavier than fire and air. Now air rises above the water and the earth, and it's translucent. But fire is the lightest element, and it'll burn, and it'll go all the way up above the air, because it's so light, according to Aristotle. Now his 5th element is ether. We don't really know if ether even exists back in his day, but it's probably what stars were made out of, all those celestial bodies that we can't even touch or breathe on or whatever. By the way, this is Clare Hill Road in Collinsville. I like this house. It's really nice when it's not being renovated. I hope you like this road too, Mr. Kaplinger.
Now see, it was thought that the Earth was the exact center of the universe. This made it really easy to say that the heaviest element tended towards the center of the universe, and the rest to follow in rough concentric circles. So, that's why the Earth is Earth.
So natural motion. Natural motion is when the elements move like towards what they've got. Earth moves downwards toward the earth, then water, air, and then fire. Forced motion is only when there's a force being applied otherwise. And it only moves away from its natural motion during the time when the force is being applied. Aristotle saw the flaw in this. He's like, hey, look at this arrow that's going even after it's been fired from the bow. He made up something about like wind tunnels, or I don't even know, to help explain that. Celestial motion will be explained by Ben.
Oh, hold on. It was theorized that the motion of celestial bodies was a sort of ideal motion. Their paths were circular. Their velocity, their speed rather, constant. Circular, constant speed. That was the motion of the heavens.
I think we should go in the leftward direction.
There are 4 causes for change.
Can't hear you.
There are 4 causes for change.
4 of them?
4 of them. There's one. That's the material cause. It describes something material. The next is the formal cause, which is a blueprint of sorts. A blueprint for the universe.
9913R. And now I'm ready.
So there's this efficient cause, and it's sort of like the primary cause of creation.
Okay.
Now,
So what's an example of that?
we have a table, let's say,
So the table maker?
The table maker would be the efficient cause.
Bam.
The act of making it, right? Okay. And there's one more here. The final cause, the aim or purpose of this material that we're talking about. For example, the final cause of a seed
Would be the plant. Very,
plant.
very.
So we got some
very.
four causes. And those are the
Those are the 4 causes. By the way, el razón de que porque no puedes ver adentro del edificio es aquí. Womp. No podemos leer. So while Ben's filming this rush, I'm probably going to discuss light objects and heavy objects. Now, light objects are going to fall upwards. What? Like that Shel Silverstein poem. And heavy objects fall downwards. And depending on the lightness of the heaviness of it, it'll fall at a different rate. Towards the earth. You know what I'm saying? Now, if Ben pans out for a second at like the top of that barn thing, I thought that was pretty cool. Check out that one. Ooh, yeah, look at that. Oh, yeah. Then it goes all the way across. Wish we could get in that building. Think it's locked? Lynch part 2? Alright, let's go. So Aristotle had this thing called a natural object. And a natural object was an object that did what objects naturally do, which is rise and fall to their natural state. Natural motion is determined by like the content of the item, the object, being like earth, water, air, and fire. Those 4. I'm getting poked by the ground, but it's okay, I guess. Also, what happens is mass and speed, ideal speed. The ideal speed of an object is proportional to the weight and the force being applied to it. And also inversely proportional to the medium that it travels through. Now this sounds really smart, but he didn't really have any way to prove this. This was all postulating back in his day. All that whatnot. Gravity and levity, concepts of all bodies moving towards their natural spot, with Earth being at the center, and then around that, water, and then around that, air, and then around that, fuego. Or as we say back in Puerto Rico, fogata. Fire. I already said fuego. Oh man, I'm a tool. Alright, let's do a different scene now. And cut.
So why do some moving objects stop, and some of them keep going? Well, Aristotle created a solution for this. And his idea was that in order for an object to move, there had to be some sort of force on that object at all times. Now we know this is not true today. We know that just because an object has a velocity relative to another object does not mean that the force is being applied on it. The sum of F can still equal 0 and an object can still be moving. It just can't be accelerating. But Aristotle didn't think about this. His simple idea was that an object that continued to move continued to have a force being applied on it. For example, to go back to the arrow idea, an arrow that was propelled out of a bowstring, in some way it was still being pushed by something. It must have been the air around the arrow, pushing the arrow somehow.
That's the one I forgot about. Oh yeah.
But some other objects don't have this force, and so they stop.
Aristotle had the concepts of form and matter. Form of something was pretty much what it was, also known as an ear. Matter is what it was made out of. So in my ear I have carbon, I have nitrogen, oxygen, earwax. All those things that Aristotle may or may not have known about. Form and matter is all around us. I hope I don't trip. The key to this is not tripping. I could do a backflip, but I might fall. I could dance, but I might look stupid. I could speak in Spanish again, but you wouldn't know what I was saying. There's some Aristotle physics for you. The conclusion scene is coming up next.
The Farmington River. The Farmington River. It's water. Water is less heavy than Earth. So look at it floating on top of the Earth.
So the one thing we can learn about this Aristotlean adventure is that science is a process. And what Aristotle was doing may not even be classified as science, but human knowledge is a process. Not everything is right at all times. It's always the best guess. We can never be 100% sure of anything. I mean, science gets us very close to 100% sure, but
Not close
there's always
enough.
some mysterious percentage of unknown.
That's a cool way to put it. Not even gonna lie. Hey, have a good summer, Mr. Kapling. I don't know when you're grading this, but peace, love, respect. Woo! Just kidding, but seriously.